Okay, yeah, so as well as CMU, I worked for Open Knowledge, a project there called School of Data. So thinking I'm going to talk about today is partly with that hat on. So people like stories, and one of the things that I'm going to explore in this talk is, float some new ideas, is just some of the ways that we can approach telling stories using technology. So you aren't my community. I wander through all sorts of communities, so I'm quite keen to learn from you as well and hear your feedback. So generally, stories progress one step at a time. We might construct them in a different way. We might construct them as quite complicated narratives. We might be going backwards and forwards in time, but generally in the telling of the stories, we're telling someone in serialised time. You listen to my words one after the other, you watch a film in some sort of sequence, even if that sequence hops all over time. So I'm going to talk about two sorts of serialised narratives. The narratives might bounce forwards and backwards in time, they might bounce forwards and backwards in terms of some sort of conceptual space or geographical space, but we're generally telling them as a serialisation. So the first sort of serialisation I'm going to talk about are story maps and narrative charts. I spent a lot of time looking at charts and visualisations and data charts. This is a very famous chart that gets drawn out a lot at visualisation conferences. Minard's map of the Napoleonic campaign of 1812 and 13. Is everyone familiar with this map? Is this a familiar map? Right. Okay, so if you're familiar with it and you know how to read it, you know how to read it and you're familiar with it. If you show this chart to a novice for the first time, they will be confused. They don't really know how to start reading this thing. One of the best ways of learning what this chart says is to watch someone narrate a telling of the story by highlighting the story of the chart. And so they start at the beginning, they tell the story of the armies moving towards Russia, and then they tell the story of the army coming back again. And there are narrations on YouTube where people talk through this chart and they show you specific bits of the chart at the time. But present that to a novice, just as a two-dimensional service, and you don't know where to start reading. Most people would not know how to start reading that chart. So that's an issue. So one of the things that I've started noticing a lot, I work in an IT department. I'm interested in technology, I'm interested in web technologies and computing technologies, and I'm interested in technologies and technological tools that people can start to use for themselves. I'm interested in democratizing technology. I'm interested in people being able to use technology practically. So this is an example of one story maps called Time Mappers, an open knowledge project originally. It's got three components. It's driven by data, it's driven by spreadsheets, by Google spreadsheets, and the Google spreadsheets contain 3 or 4 columns. The columns contain a date, or a range of dates, a from and a to date. They contain a set of coordinates, latitude and longitude, or a place name. They contain a description, and the description might also link to images. And what this application does, it will take that data feed from Google spreadsheets and it will give you a time map. It puts the dates onto a timeline, puts the points onto a map, and it puts the description of the currently selected item in the middle of the window. So this may be something that's familiar to you all. As I say, wandering through communities, I don't necessarily know what communities are familiar with. If you select one of the items on the timeline, it's highlighted on the map and you see the description in the panel. There are other time mapping solutions. Similarly, time maps was quite a popular one. There again, you'd have a timeline with a map and descriptions, and the points on the map in the similarly timeline would correspond to those in the field of view on the calendar. So you could slide the calendar, and points on the map would come in and out of time. So that's for looking at points, and you can sort of see how things relate to dates in that. But again, for reading it as a story, it's not necessarily obvious how you read through this as a novice. You can construct it out of time, but again, reading through it and reviewing your work, what's the best way of reviewing that? I can click on points and see the descriptions of those points that appear in the timeline. I can go through the timeline, but it's still ambiguous what a single telling of this narrative would be. So there's another tool, this one came out last year maybe, from Night Lab, and a lot of the work being done in these digital storytelling ideas is coming from a community that would label itself as data journalism. So it's news community, so we're doing lots of interactive storytelling. So storymaps.js, this is an example from the Times. Here you've got, again, a sequence of points connected in time, so you go from one place to another place in the telling of your story. click on a marker or click on an arrow, you get a marker in a particular place with a particular event happening at a particular time. Got a description and an image, it might be a video. When you click forwards, there are lines connecting places. So you've got stories here where you've got geographical locations connected in the story that you're telling. And when you click on one of the arrows, it takes you from one point to the next point along the line. So you've got connected points. In this one, we've just got points, right? In this one, we've got connected points. We're going from one place to another place in the telling of our story. So again, that's another way of telling stories. And again, you can build these stories up. Name of a place, some sort of description, a geographical location, a time and a date. This is the data you need. And to construct complicated narratives, you can create those dates in a spreadsheet or a file in any order you want, and then you can sequence them. So you can tell your story, you can put lines in your spreadsheet, you can think, I've missed out a step, I can insert it into the spreadsheet, and it will be inserted into the map. So we can construct these stories, and stories can emerge just by us putting together rows and rows of data. Then that's another tool that's being developed at the moment by CartoDB, who are an online mapping group. This is still in its early stages, I think. I don't know if there are any good examples of it used. Has anyone seen this? No, well, this is Joe. So this is, I think, something you want to watch. I respect CartoDB, so I respect the things CartoDB do, so this is one to watch. This is another sort of chart. This was popularised by webcomic XKCD, which if you do, if you play with data, or if you're a computing freak, you know XKCD, you know Dilbert. So does XKCD come as far as this community as well? A few, yeah. For those of you who aren't familiar with XKCD, XKCD. Read the comic, hover your mouse over the image, you see the tooltips. There's lots of jokes in as well. So there was an XKCD comic that was doing narrative charts for, I think, Lord of the Rings, or for Star Wars maybe. And this was brought to my attention again by a chap called Michael Smethurst, who's a BBC R&D developer. It's Fantastic Life on Twitter. And he was looking for something to produce these sorts of charts for continuity. There's a radio drama being produced, they want to do continuity checking. And the way you read these charts, you've got some notion of time along the bottom. And we can go into all sorts of issues about what time means when you're watching stories. But there are scenes. There's a scene here. There are little lines representing scenes. And this axis, we've got, this is a categorical axis, we've got names of people. And what happens is that the people has each got a line, and the lines group together in particular scenes. So you get a telling of the story through a text of how people are coming together at different scenes in time. And so we can, it can get contentious. How we structure time along the bottom. Is this time of watching a programme? Is this time in terms of the internal time of the world this story takes place in? So that can get a bit complicated. But there is a tool that allows you to just take a set of data and about names of people in scenes, and it will generate these sorts of charts for you. Okay. Still a little bit difficult at the moment to use, but it'll get there. Another couple of iterations in this tool. You just need to have lists of 2 columns, person, scene. Right, that's all you'll need, 2 columns of data. And it will draw these charts for you. This is another example of just weaving your way through texts over time. And again, this is just visual representations. I don't know if this is familiar to any of you as text. Here it's called sentence drawing. This one is sentence drawing of the story of Romeo and Juliet. Each of the colours here represents one of the families. Each line is a particular person speaking, and each turn is a change in turn of speaker. So you just get characterisation of the structure of a play through this visualisation of it. The colours tell you where you've got different colours, whether or not you've got groups of people from the same family, whether or not you've got different families, 3, 4 families in this scene. So you can just get a visual representation. Again, it's quite hard. This is a sort of a flat view over the whole of the story. It's hard to read. Well, you can read it. You can go, this person's got a long speech, a smaller one, then there's a bit of quick-fire dialogue, and there's another long speech, and so on. So you can get some sense of how you read that. So that's one set of stories, just how we go about sort of linearising texts and linearising stories and linearising, the coming together of peoples through the telling of a tale. Something that can give you an overview, a macroscopic view over a whole text in one glance. Lots of time researchers look at microscopes, at very small things. Other people take an approach, you step back, you try to look at everything all at once. Right? So this is what these macroscopic views do. They let you look at everything all at once. And the technology is helping us get better at finding ways of developing these macroscopes. So the other thing that I want to talk about as a sort of linearization or serialization technique is a notion of notebook computing. I come from the computing department, and I play with code, and I think it's a useful tool that I can use to build other tools. And I'm quite keen in finding ways of helping other people come to code, so see the light in code. And notebook computing is full of rich metaphors, actually, about helping people engage and helping them rethink what programming might be. So there are two particular ideas that I want to draw out about the notion of notebook computing. One is literate programming, and the other one is called reproducible research. So literate programming is a phrase that Don Knuth, a guru of programming, an artist of guru programming, came out with. And he was looking at ways in which software developers produce code and document code. And one of the things he was keen is, and one of the things that he saw as being a valuable thing, was the notion of literate programming. Literate programs are programs that are self-describing. You can read them as stories, narrations. The code is fully described, and you can describe yourself. And literate programmers are people, they're essayists who write programs for humans to understand as well as for machines to execute. Right? Programs for machines to understand as well as humans to execute. Most of the time, most people think of coders and developers as doing really, really difficult, complicated stuff for computers to understand. Right? If you start producing things for humans to read, then maybe more people think, oh, well, I can write stories for humans to read, so maybe as a side effect, I can also write stories for computers to read, stories for computers to execute. Maybe that's one way we can help people come to see the utility of computing and think they can engage with it. The other thing is reproducible research. And so this is an idea that's been floating around for a few years. And reproducible research, this is one quote describing it: research papers with accompanying software tools that allow the reader to directly reproduce the results and employ the methods presented in the paper. If you have ever tried to replicate a paper that claims to be a computing paper, it claims to tell you where the data is, claims to tell you what the algorithms are that we use to produce the results, claims to be able to generate the graphs shown from the results they've also quoted, I defy you to find papers that are replicable or reproducible. Most papers miss bits. No matter how well-intentioned you are, most papers miss bits. Any researcher who has produced a chart using Excel or some other tool, complicated chart, ask them a couple of years down the line how they produced that chart, and they will be flummoxed. Oh, I'm not sure. Can't quite remember. Don't remember where the data is. Maybe the tools of today don't work with the tools of yesterday. So these reproducible research papers allow you to reproduce research. You write a document that contains the code and the data processing, the statistics, all the algorithms in an executable way so that you can rerun the research contained in that paper. So one of the tools that's getting very popular over the last couple of years, it's being developed actively at the moment, it's got funding for development for another few months, is called an IPython notebook. Python is a programming language, and this was developed to allow you to write and execute Python code, although it will allow you to execute other programming languages as well. JavaScript, Ruby, a wealth of others. It comes in three parts. It runs in a browser. You can run it over the web. And it comes in three parts, and I'll just sort of describe the three parts of it. First one are markdown cells, which are text cells. You can write text in this document. There are cells here, separate cells. You can double click on there and I'll be able to edit that text. This is a header, right? Top level header, you've got 3 or 4 levels of header. There's another text cell here. I could just double click on this, type text. The language I use to type the text is a markup language called Markdown. If you've ever written, you may or may not like writing raw HTML, but if you've ever written an email and put things in stars for emphasis, that's what writing Markdown is about. It's using really simple forms of markup to get emphasis across. So we can write text, we can write large blocks of text, we can write documents, we can write essays. I could write a single text cell if I want the whole of my document, just a text document. I can put pictures in there, I can put movies in there. The nice thing about the cells is if I wrote my one block of text, paragraph at a time in a separate cell, I can do 2 little arrows. I can move the blocks of text up and down so I can reorganise my narrative in quite a nice, friendly way. Okay, just like copying and moving blocks of text, but it moves it around for you. So those are text cells. We can just write text. We can just write stories. We can just write article papers. There are also code cells, and the code cells contain code. I use Python, you can use JavaScript, you can even use other languages as well. When you click in these cells, you can write the code. I can write multiple lines of code. Here I've defined a function, geoannotate data. Here I'm calling the function geoannotate data. I'm taking sort of 2-column data. I'm taking 2 column names and I'm getting latitude and longitude from it. So I've written one bit of code and I can test that, and then I've got another bit of code calling it. And if I run that piece of code, I can look at the result. Right? So I can execute my code and look at the result after each step. I can display the output of the result of each code step. So I can build up programs from very small chunks. These chunks might have been written by other people. Someone else might have written the program to geoannotate the data, and all I have to do is use this stuff. Right? So I can write simple, I can do powerful functions. If you use a spreadsheet, you use any computer application, you have menus. You select some data in a spreadsheet, you select a menu option, it does something to the spreadsheet. I've got a set of data in my machine, I go to a menu item, I have this function, it applies this function to the data. Right? This is just like going to a menu item, essentially, in a spreadsheet. And we are casting an incantation in words rather than going up to a menu, down to a menu item, across into a sub-menu, down, across, and writing what action I'm executing. And I can have a linear sequence of these things. And then we get the code outputs. So here's the code output. By default, it shows you the last thing when at the end. If you have a block of lines of code, it shows you the state of the last one. So this is, this is for the geeks to read. This is JSON code. You can get tables. So I can display a table, a data table. So I can do some process, I can have some data, I've got some data, I've got a function that does something to that data, I'm applying the function that I define there to that data, and here I'm looking at the table that I generated by applying that function applied to that data. Okay? So I've gone from data to the function that's applied to the data, and I've got the table out. I can do other functions. So this is just a little bit of code that's taken the data frame a couple of steps up, and it's plotted it on the map. And it's inserted the stuff in the map. So a couple of lines of code, create map, take map from a data file, create map from it, embed the map in the page, and I've got this thing. Okay, the data is referenced further up the page. The whole thing is self-contained. You can replicate this. I can empty all the output cells, I can give you this document, you can rerun the experiment and get all the answers out again. Right, it's replicatable, it's reproducible. There are no bits missing. It is what it is, right? It contains it all. So, one of the nice things about these notebooks is that you can construct your analyses over time. You can build up your analysis. You can comment. One of the ways of writing these notebooks in a literal way is you can do a description up here. This is what I'm going to do. Here's my bit of code that does it. Here's the result of the code, and then I can have more text. This is my analysis, this is my interpretation of the results. This is my conclusion. Right, we can go from introduction, method, results, conclusion. Very small blocks. We can put these all in our living documents, our reproducible documents. And we can produce rich outputs as well. So that's just one of the things about these documents is that you can construct your story one step at a time. And going back to the maps as well, but we've increasingly got technologies that allow us to tell or read stories one step at a time. So if you go back to Minard's graph, I don't know where to start reading this, but we've got technologies, just simple maps, simple sequence maps that take you from one step to another, maybe take you from one step to another via a line, so you can see how points relate, how people travel along lines. So that's my presentation done. There's more bits of this I'm thinking, and increasingly tools and tutorials on using all of these technologies on schoolofdata.org.
Excellent. Thank you.
Thank you.